Greetings. A task that's not directly related to my 10 gig system, but it will be required to better listen to the 10 gig signals with my dish is to add a waterfall display or a Panadapter, call it what you like, to my FT-817, my IF radio, the radio that will be receiving those signals. And well, in order to do this, there's a mod that can be made. In this case, it's a mod that W1GHz Paul distributes. And when I ordered my transverter and tripler boards, I also added this little board that is designed to bring out the IF signal. It's the first IF signal at 68 megahertz. Bring it out to the rear panel of the FT-817 in order to be able to see wide. So if you're trying to receive a signal and you don't hear it, it may be off frequency. Without a Panadapter, so a display of the spectrum that you're trying to receive to locate the station, it could be hard to find a station because you have to first point your dish very accurately and then try to find the station if it's not dead on. So it's a lot of variables that at least you can eliminate one of the two by using a Panadapter. So the idea, of course, is to take the 68 megahertz coming out of this little amplifier board and send it into a SDR receiver, whether it's the RTL SDR 8-bit USB device like this, cheap one for less than $20, or to something more fancy like the SDR Play RSP1A, which I own. This is 12 bits of resolution. This has only 8 bits of resolution, but it has a lot of sensitivity. So an 8-bit RTL SDR receiver is more than sufficient to listen to the signals that will be provided by the FT-817. So we'll be tuning to 68 megahertz, of course, and then on the PC screen, laptop or netbook, whatever, we'll see what's on the spectrum, certain width on both sides of the center frequency we're looking for. So that's my solution. As far as installing the 68 megahertz connector, I have a choice. Is to simply use a pigtail like this, an SMA, drill a small hole and bring it in and solder it directly to the PCB. But then you're stuck with a pigtail on the back of the rig that you cannot remove. Or simply install a connector like this. It could have been an adapter, SMA, but I'll instead be using a connector. Install the connector here and use a small piece of coax, a permanent coax going to the PCB. From that connector, and then you can connect and disconnect on the outside using an SMA cable. So that's very likely what I'm going to be doing. The hardest part in this whole modification is to indeed drill the hole in the rear plate right here. It's pretty thick and you don't want no drilling shavings to get onto the circuit. So what you do is you drill it with upside down like this, so that any piece of metal will fall down on the table and not go into the circuits. But it's a delicate exercise, and there are 2 ceramic filters here that we need to avoid with the drill bit. So I'm gonna do it slowly but surely. So that's the intent for today, and I'll show you the end result once it's done. There you go. Job done. It took me more than an hour to do it, probably closer to 2 hours. I wanted to go slowly, make sure I don't make any mistakes. So the board is installed here, ground connections on the can here like it's done on the document, and then the small coax cable. It's a Teflon coax, so impossible to melt, and that's a good thing because it's pretty small. So I soldered and installed into the connector. Drilling the connector hole was not necessarily easy, but it was not hard. Like I mentioned, I flipped the radio over and then started with a very small drill bit and then went 2 steps in size in drill bit. So I must have drilled 5 times really slowly with a cordless drill. I could count the turns on the bit. and never went through hard. It just, as soon as I felt that it was through, pulled out the next bit, etc., until I got to the right size. So that went well. Now, the soldering job on this board, that's sort of easy if you've ever done some surface mount components. It's 1206 size, so manageable. But soldering down to the board on the FT-817 under this added-on PCB, that's the harder part. You need to have very, very fine tips. Like I have this JBC soldering iron, which is very small, very, very small tip. You need to use some flux. You need to scrape off some solder resist, the green varnish. And I used wire wrap wire, which is 30 gauge solid, to do the two connections underneath. Not easy. So if you're not experienced doing surface mount, don't do it. Ask someone else to do it for you, someone who's experienced and equipped for surface mount soldering. Otherwise, it went well. I used some double side adhesive, and I pressed the board onto the adhesive. It's tape, it's really double-sided tape, and then soldered the two wires here to the can, and then finished off with these two wires which I had soldered down onto the board. So that's it. Now I'm anxious to see if it works. Let's go try it out. So radio powered up, tuned to 144,000, 144 megahertz even, and I have the IF cable coming out and going to the RTL SDR, which is connected to the laptop. Now I'm injecting a signal from a signal generator at the minus 110 dBm. That's a quite low signal into the radio, 144, and we see it on the screen. Once I've adjusted the offset for the IF, so that's adjusted into the software, it displays 144. And you can see the peak here, and I can obviously move the receiving here, and that is pretty much bang on. There's a little bit of an offset, but it's really crumbs. So if I change the tuning frequency on the radio, you can see that the radio does tune elsewhere. Now the problem is our tone that the generator sends is out of the receiver window. So it's off, but this would allow us to detect, for example, a station that's 5 kilohertz off. Say we're looking for a CW signal. Well, we would see it. Say, oh, there's a signal right there. So all I have to do is move the VFO and bring it into the window here, and I can bring up the volume, and the tone is there on the radio. See? So that's great. That's one way of operating, using the receiver on this radio to listen to the signal, and use this just to locate the station we're trying to contact. Now we can also use this as a receiver. The laptop is a demodulator as well. So if you bring up the radio here, and you can tune independently of this, if the signal is gone, you can tune to that signal on the laptop and listen to it. It's got better filtering, definitely better filtering. You can narrow down the filter to something really narrow, which this radio cannot do because it's not SDR based. So that's one good thing. If you're really struggling to listen to a signal, you can use a laptop to pull it out of the noise. Now, you have to remember that you're transmitting on a different frequency. You're transmitting on this frequency. So, the best thing is to not touch this. Leave it always to 144. So, if everything is properly aligned and the offset are set properly, this is what we're listening to. And then tune here. Go up and get that signal into the window. And then it will correspond, and you can use this to listen if you wish. Listen to the received signal, but never touch this here. Leave it to 144,000 and tune like you'd normally do with the VFO. Look up for your station. Okay, so two ways of receiving. So it works very well. As far as sensitivity goes, I'll bring down the tone. I'm at 110, 120, 130, 140. That's the lowest that this generator can go. Minus 140 is in the 20 nanovolts or something like that. It's really small. So this setup using the RTL SDR will be more than sensitive enough to decode whatever's coming from the transverter, because you have to remember the transverter has a noise floor that brings everything up anyway. So the sensitivity of this thing is not important. What you want is some dynamic range, of course, and we may end up attenuating the signal, reducing the gain on this SDR receiver, because whatever is sent by the transverter will be too strong, too powerful. But what matters in the end is the difference between the tone or the signal that you're receiving and the noise floor of your receiver, which is not the noise floor of this. The noise floor of the transverter will be much higher than noise floor of this guy. It's not the sensitivity of this radio that's going to limit us, nor will it be this one. It's really the transverter, the preamp at 10 gigahertz. That's what sets the noise floor and the difference between the signal you're receiving and the noise floor. There you go. Job done. On to the next piece of the puzzle. 7-3.